Okay, so we want to find the absolute minimums and absolute maximums of this function over this rectangle. Okay, so first off, there's always kind of three steps to finding these absolute extrema and stuff. So first thing is to find the critical points of f. Okay, and remember that is when f of x, the partial derivative with respect to x is equal to 0, and when the partial with respect to y is equal to 0. Okay. Uh, then the second thing is to find all of the extreme values or the extrema on the boundary. And then the last thing is you just compare those and figure out, okay, out of all of those, which one's the biggest, which one's the smallest. So let's say we have this function f of xy is equal to x squared minus 2xy plus 2y, and the region that we're looking for the max and mins on is this rectangle where x is between 0 and 3 and y is between 0 and 2. Okay, so the first thing I want to do is I'm going to go ahead and find the critical points. Okay, so I'm going to be able to see that. So I know, I have a hard time using computers sometimes, but I know, what are we looking at here? That the partial with respect to x, okay, would be 2x minus 2y, okay, and the partial with respect to y, okay, is going to be negative 2x plus 2. Now we want to know when these things are equal to 0. What points does that happen? So it's easiest to start off with the one that only has the single variable over here. And so negative 2x plus 2 has to equal 0. So the only thing that happens there is that x has to equal 1. Well, if I know x equals 1, now I can go to the other one. Say, well, I know x has to equal 1 because that's the only option, right? If x had equaled multiple things, then I would have to do it for each one of those. Okay. So solving this thing again, we get y equals 1. So my critical point is just the point 1, 1. Right? Now, f of 1, 1, we evaluate the function then in, what was it, x squared minus 2xy. I'm going to have to substitute in the ones for all of those, right? So that's 1 minus 2 plus 2, so that's going to be equal to 1. So I'm getting a lot of ones here. Okay? So those are the critical points. And now we have to worry about the boundary. Okay? So with my boundary, that boundary is when x equals 3 and y was, what was it? 2, between 0 and 2. So that's this rectangle right here. Now, I'm just going to start labeling this. I'm going to call those L1, L2, L3, and L4. Okay, so L1, that is just simply the line x equals 3. Okay? So what we're going to do is we're going to put that, whatever we get for that boundary, whether it's a constant or some other variable thing, we're going to substitute that in for x into our function, and we're going to look, in this case, at this. Okay? And that's going to be, so if we put 3 in for x, 3 squared minus 2 times 3 times y plus 2y, 9 minus 6y plus 2y, so that's 9 minus 4y. Okay? And we want to find all of the maximums and minimums on that as well. Okay? Now, we go back to calculus 1 for this, because we just have a function in a single variable at this point. Okay? So we can look and see kind of when the derivative's equal to 0 and all that, but we can also just observe this is a straight line, right? And it's a decreasing function. So since it's decreasing, the lowest value of y is going to be where the minimum is. Okay. And then we get the maximum, right? So at one end, okay, we have the point 0, 3 down here, and this is the point, 3, 0. This is the point 3, 2. So at 0, we'll get, it's decreasing, so the 0 is going to be where the maximum is. So 9 minus 4 times 0, that would be 9. Okay. Cancel that. And then the minimum would be on the other end of it. So that's 9 minus 4 times 2, which is going to be equal to 1. Okay. So this one gives me the point to look at. The y is 1, and that is 3. This is the point 3. Let's see, hold on, wait a minute. I wrote that wrong. That at this point, f of, I didn't give myself enough room, did I? So f of 3, 0 is equal to 1. F of 3, 2 is equal to 9. Okay. So on that boundary, these are my minimum and maximums. Okay, and it just happened to occur at the endpoints. It doesn't always happen at the endpoints. Okay. Now we'd have to do lines 2, 3, and 4, right? So let me give myself some more space down here. Now what's going on here, and let me just kind of show you, I got a Mathematica thing here. So here's a graph of the surface, the x squared minus 2xy plus 2y. It's got this curvy little shape to it. And right now we're looking along where x equals some constant, right? And so this is when it's equal to 3. It just makes that straight line. So notice it's a decreasing function, and you can see it plotted on the surface over here. Okay. So right here you can see it's going across that. And we're just looking at that part of it, right? When we look at x equals 0, and the other side of that rectangle, it's just going to be a flat horizontal line. Okay. And that's way over here at this edge. Okay. Now, when we look at the other lines, that's when y equals certain things. So y goes from 0 to 2. And you can see on this side, when y is equal to 0, that curve that it makes is this kind of parabola thing, which, hey, it's still a increasing function, so we're going to use that idea. But then when it gets up to 2, you can see now, I get it to sit on 2. It looks like there's a little minimum over here that's in the middle of that. So if you look at it kind of edge on, you can kind of try to match it up, but it's hard to see where the surface is kind of stretched out there. Okay, but that cross section makes this piece of the parabola. So when we get to that, we're going to have to look at where the vertex is and stuff like that. Okay? So I'm going to go ahead and do the left and right sides. Why not? Okay, so we've got L1. So let's look at the L3 and see what's going on there. Okay. So with L3, that's where x equals 0. So we're looking, put 0 in for x. Okay. So if we put 0 in for y, for x for our function, you're going to see that we're just going to wind up with 2y, right? It's the right. That's an increasing function. Okay. And so that means that the endpoints is where you're going to hit your minimum and maximum. So we have one endpoint at 0, 0. The other endpoint is at 0, 2. Okay. And at 0, 0, we know the function evaluated there is 0. The function evaluated here is going to be 4. So I just got to keep track. Okay, those are my possibilities for my mins and maxes that I've found so far. And now we got to do the top and bottom. So L2 is where y equals 2, right? So that's this horizontal line up at the top, up here. So if y equals 2, then we're looking at f of x2. So that's x squared minus 2x times 2 plus 2 times y. So that's x squared minus 4x plus 4. Okay. Now, on our interval from 0 to 2, I don't know offhand if that is strictly increasing or strictly decreasing. So what I want to do is I want to check the endpoints, and I want to check where its derivative equals 0. Okay, so I guess in my mind, I'm thinking about this just being its own little function, f of x, and I want to say, okay, well, I look at its derivative, and that's just 2x minus 4. So when is that equal to 0? And that would be when x equals 2. Okay, so it does actually occur at one of the endpoints, right? Because the other one was when, or no, it doesn't. Okay, so we have the point 0, 0 to evaluate it at. 0, 2. That's that bottom left corner. Then we're going to have the point where we have x equals 3, 2. That's the other top corner. And then we're going to have the point when x equals 2. So that'll be the point 2, 2. So remember, we're on that boundary, so y is always equal to 2. So now evaluating my function at that point, we're going to wind up with 4 in this case. We can use this, because we've already substituted 2 in for the y, right? So that's going to be 0 squared minus 4 times 0 plus 4. This one's going to wind up being 3 squared minus 4 times 3 plus 4. So that's going to be 9 minus 12, right, plus 4. And not a lot of room. Negative 3, so that's going to be 1. And then we'll have 2 squared minus 4 times 2 plus 4. And so 4 minus 8 plus 4 is going to be 0. So, and notice here that out of these possibilities, the lowest one on that didn't occur at an endpoint. Okay, so you've got to check, because when you narrow it down to that cross section, you're really talking about a function on one variable, so you still have to use your calculus 1 stuff to find mins and maxes and stuff. Okay, and then the right hand, or the bottom, okay, is when y equals 0. Okay. So L, what did I label that one? L4 is when y equals 0. So for L4, we're looking at the function fx0, which is just going to be x squared. So at the origin, that left side of it, that's just going to be 0. At the far side of it is going to be the point 3, 0, and that's going to be 9. And of course, when I check the derivative here, we already get that one thing, because 2x has to equal 0. Okay. That means x is equal to 0, so we already have that point. So now I've got all of my work done. All I got to do is just check and see which of those numbers is the largest and which ones are the smallest. So what do we have? We have 9 being the largest out of all of these, because that's 9, 0, and that occurred in 2 different places, right? Because that occurred way up here at the point 3, 2 as well. Okay. And then my lowest out of all of them would be 0, and that actually occurred at a couple of places. So we have my minimum is 0. My maximum value was 9, and this thing occurred when we had 2, 2 in the domain, 0, 0, It occurred at a couple of places, right? And let's see, where else I took out a 0? That was 0, 0 again. And then 9 was at 3, 2, and again at 3, 0. So that occurred at 3, 2, and 3, 0. Okay. So check your boundaries. Whatever your boundary is, you substitute that in, okay, and look for the min and max of that that cross section, that new curve. Okay. Check your critical points, and then just compare those. So I got one more to look at here that has something that's not rectangular. Okay. So I'm going to focus on thinking about the boundaries here. Okay. So in this one, we have a triangular region. And the points are at 2, 0, 0, 2, and negative 0, negative 2. So that's this triangular region in here. Okay. Now, L1, okay, I'm going to call this is L2, and this is L3. So L1, that line, is what y equals negative x plus 2. Okay. You can just use slope-intercept formula going from the point 0, 2 to 2, 0. And then L3 down here is y equals x minus 2. And then L2 would just be when x equals 0, would be the equation for that. Okay. So along L1, if y is equal to x, what we're looking at is this function. Okay? We'll substitute negative x plus 2 in for y. And let's see, that's going to be x squared plus x squared. That's plus 2. Okay. I square that, then we're going to get a minus 4x plus 4. That's 2x squared minus 6x plus 4. And we want to know along that, of course, where are the kind of the mins and the maxes and stuff. So again, I want to think about when its derivative is equal to 0. So when is that equal to 0? So that's 4x equals 6, so x is 3/2. So that would be at the point 3/2. And then the y coordinate would be what? Negative 1.5, 1/2. Hold on, I need to grab my calculator, make sure. Oh, yeah, because it's along that line, so 1.5, so that'd be 1/2. Okay? And we want to evaluate our function at that point. Okay? So that's 2 times 3/2 squared. So that is at a negative 1/2. Okay? And then at the end points, okay, so, and remember I'm along this top line, so my x-coordinates is going to be 0. And since it's along this line, if I put 0 in for x, that means the y-coordinate has to be 2. Okay? So I evaluate it at 0, 2, and that's going to turn out to be 4. Okay? And then on the other endpoint, over here, okay, the x-coordinate is 2, so the y-coordinate is going to be 0. Okay? So if the x-coordinate is 2, that's what 2 times 4 minus 12 plus 4 would be 0. Okay? All right, so those are the values of the functions along that line. Okay? Then I'll just work my way around. L2, we know x is equal to 0. Okay? So we're looking at this one, f of 0y. Now if I put 0 in for x, that's just going to leave me with y squared. the corner points on that one. So y squared on that interval, you need to be careful because the derivative then, of course, is 0 when y is equal to 0. So we have 3 points to check: 0, 0, 0, negative 2, and 0, positive 2. Right? So I'm going to look at my function along at each of those 3 points. And at 0, 0, that's going to be 0. At 0, negative 2, that's going to be 4. And at 0, 2, that's going to be 4. And then lastly, I want to look along the L3, which is x minus 2. So along L3, we get y equals x minus 2. So that's x squared. Make sure I get this right. Y squared and negative 2x plus y squared minus 2x. Make sure my signs are right. I always like to double check things. Okay, plus. So that's going to be 2x squared minus, that should have been a 4x, sorry, minus 6x plus 4. And you'll notice that's exactly the same as the other one we did. Okay, so just to save our brain from doing too much, that's exactly the same function we had along the other border. So the values that we need to look at and compare are these, and we just need to know which one's the biggest, which one's the smallest. Okay, and the minimum value is negative 1/2. That occurred at 3/2, 1/2. And then our maximum value is 4, and that occurred at 0, 2, 0, negative 2, and 0, 2 is already listed, and those are repeats. All right, so the maximum value is 4. It occurs at 2 different places. That's fine. The minimum value is negative 1/2. Oh, wait a minute. I didn't check the critical point. Okay, so I need to know. So I might need to amend that. When I look at the partial with respect to x, what was that? It's going to be 2x minus 2. And the partial with respect to y is going to be 2y. All right? Yep, 2y. So that's going to be when, so my critical point is at the point 0, 0, because we want to know when is 2y equal to 0. Well, the y has to be 0, and then the other one tells me that the 2x minus 2 has to be 0, so the x needs to be 1. Okay, so I do need to check that point then into my original function, because I don't think that was any of my points back here. No. So I need to check the point 1, 0. So f of 1, 0 is 1 squared plus 0 squared minus 2 times 1, x squared. I'm always double checking. I make lots of simple mistakes, so I always like to be real careful about signs and things like that. So that's negative 1. Ooh, that's the minimum then, because that was definitely less than the negative 1/2. Okay, so I need to go back up here and fix this and go, oop, that was wrong. Okay, so my minimum value is negative 1, and that occurred at the point 1, 0. All right, I hope this helps with the Absolute Extrema. If you need some more help, please let me know.